5.5 is complex numbers. So in this section, we're going to be doing some computations with imaginary numbers. Before, all we had to do was identify, is a value an imaginary number or not? That's when we were taking the square root of a negative value. Here we're going to just do some computations with them. Okay? Again, we're not going to get into graphing them, but just adding, subtracting, multiplying, and dividing. Okay? So how do you do computation with complex numbers? And first, the imaginary number, identified with the I, 3i, negative 2i, and that's just showing that value is imaginary. It's not going to fit on the normal coordinate plane that we've been dealing with since maybe 6th, 7th grade. Okay? Now, a complex number, this is a mixture of a real number and a imaginary number. A plus bi is the formula it needs to be written in. A is considered the real term, the real value. B is the imaginary value. So when you're writing it, make sure the imaginary value comes second. 5 plus 9i, imaginary comes second. Negative 3 plus 2i, imaginary number comes second. Positive, negative, these terms don't matter so much. It depends on the order of the real number and imaginary. I want to see the imaginary number come second, so start off with the real value. Okay. Now we have to think about what is the value of I squared. Okay. We know I is going to be when you take the square root of negative 1. Okay. So let's think about how we can break down what I squared is. Okay. We know, I'll put it over here, I equals square root of negative 1. Okay. So if we have I squared, think of another way that can be written. That can be written as I times I, or square root of negative 1 times square root of negative 1. Okay. Now, if you square root negative 1, think about how we're doing this. When we rationalize the denominator, we multiply two radicals that had the same radicand, the square roots just cancel each other out. Well, that's basically exactly what's happening here. Square root of negative 1 is negative 1. The square roots are canceling out. So I squared ends up being negative 1. Okay. Now, let's move that on to I cubed. Okay. Well, we can break down I cubed into I times I squared. And we have I squared, we're going to switch to negative 1. And that means I cubed is negative I. Okay? And let's break this down to I to the 4th. I squared times I squared, negative 1 times negative 1 equals 1. So going through all of these, you can see that we can simplify i's. You should not have an imaginary number that the I has an exponent with it. So each time, you're going to have to simplify it. Now, you could keep going on this way. You could now do I to the 5th. Okay? You could split it down to I times I to the 4th. I to the 4th goes to 1. I times 1 is I. Okay? And that's just showing that rotations ought to keep going, because I to the 6th now, I'm going to break this down to I squared, negative 1, negative 1, negative 1. And that would simplify to negative 1. Okay? That 4-step rotation keeps going over and over and over again. I equals I squared equals negative 1. I cubed equals negative I, and I to the 4th is 1. And it just keeps going over and over and over again. Okay? So as long as we can remember that, and that's what I want to put up over here. Okay? I equals I squared equals negative 1. I cubed is negative I to the 4th is 1. And as long as we remember that, you should be able to figure out any value and not really having to break it down like we did here. I to the 12th. Without breaking it down to I squared like I did for I to the 6th, let's just think. We have a 4-step rotation here. Okay? 4 goes into 12 3 times. It goes into it evenly. So 4, that means I to the 12th is not simplified just to 1. I to the 21st. Well, 4 goes into 21 5 times with a remainder of 1. So since it's a remainder of 1, we start back at the top again. So that means I to the 21st goes to I. If it goes in evenly, divides by 4 evenly, it's not simplified to 1. If there's a remainder of 1, remainder of 2, remainder of 3, now it corresponds with either I squared, or I cubed. Okay? So 4 goes in evenly, breaks down to 1. So one more example here. If I give you I, let's say to the 34th, okay? Well, if you take 34 and divide it by 4, 8, remainder of 2, since we have a remainder of 2, I to the 34th goes to -1. Okay? So that's how you're going to have to remember this. I'm going to leave this up, but this is something that we should know. Okay? That rotation, as long as you know that rotation, you don't need to remember every single I value. You just need to remember those 4. Now, when we're doing computations, adding and subtracting, I is just another variable. Okay? Combine the like terms. So if you're given values like this, 5 plus 9i plus 2 minus 4i. Okay? Combine the like terms. 5 plus 2 is 7. 9i plus -4i is 5i. 10 minus 4, let's watch our signs. -3i minus 9i, -12i. Okay? Make sure it goes real number, then imaginary. Real number, then imaginary. Adding, subtracting, just combine the like terms. Don't do more work than you have to. Okay? For multiplying, it's the same work. You're going to either, however you like to say it, either FOIL or double distribute. I'm going to multiply my 5, giving me 40 plus 20i. Multiply the 2i gives me 16i plus 8i squared. Now I said the rule here is you can't have an I with an exponent. So what does I squared go to? I squared is going to go to -1. So it's actually 8 times -1. So let's simplify a little bit. 20i, 16i gives me 36i. 40 plus 8 times -1. So this is actually -8. Multiplying those together switches it to -8. 4 minus 8 is 32. So I'm left with 32 plus 36i. Okay? You need to simplify. This was just combined like terms. I squared, you need to simplify that to -1. 9i times 3 minus 5i, just another example. This time it's distributive property. So we're going to have 27i minus 45i squared. Okay? So we do need to move some things around and simplify. We have the I squared again. So that I squared goes to -1. -45 times -1 is 45 plus 27i. So we had to move the 27i to the back, and we did have to simplify that I squared. 6i to the 4th, 9i to the 6th. Multiplying these, and we get 54i to the 10th. Okay, now here's one where I'm going to use my rotation. How many times does 4 divide into 10? Okay, 4 divides into 10 twice with a remainder of 2. So since it's a remainder of 2, that I to the 10th is going to simplify to -1. So it's actually 54 times -1. 54 times -1 is -54. Okay? Think about how many times 4 goes into 10. Let's do one more example. We have 5i cubed times 8i to the 9th. 5 times 8 is 40, and it's going to be I to the 12th power. Now this time, how many times does 4 go into 12? 4 goes into 12 evenly. It goes into it 3 times. There's no remainder. So that's not simplified just to 1. 40 times 1 is 40, and then there's your answer. Okay? So this is what we need to remember. What does I equal? What does I represent depending on what the exponent is? And if you remember these 4 steps, this 4-step rotation, you should be able to simplify any I value without having to use your calculator and just think about what is the remainder, or does it go into it evenly. Okay? Second part is on division. Division's a little bit bigger, a couple more steps, the problems get a little a little more work to it. So what I'll do a second video for that one.